Okay, here are a few homework problems from section 1-2. In exercise 1 through 6, you're supposed to find the slope y-intercept of the line specified by the equation. So with these are similar to section 1-1. You just solve them for y. Like this one, maybe you would take the y to the other side and get y equals 5x plus 3. So you add y to both sides. So there's nothing new with these. So in this one, take the 7x and the minus 30 to the other side. You get 6y equals negative 7x plus 30, and then divide through by the 6. So these you're solving for y, and then you're getting the slope in the y-intercept, and you could even use Excel if you wanted to, but you have to solve these for y. So there's nothing new there. This is something new. Okay, exercise 7 through 14, find the equation of the line that passes through these points. Here's the first one, problem number 7. 5, negative 1, negative 5, 5. All you do here is put those data points right here in the linear equation area. So here's the first one. We have a point 5, negative 1, and another point, negative 5, 5. Now once you get those in there, then all you do is click the get equation from data points right there, and there's the equation. The equation is y equals negative 0.6x plus 2. There's the graph of it, and if you wanted to find the x-intercept, there it is at 3.330, y-intercept at 0, 2. You can change your viewing window right here. So that's how you do all those problems in this area right here. On this one, exercise 15 through 22, it says find the equation of the line that goes through the point with the given slope. So we have a point and a slope. So to do that, use the right hand side of the sheet over here, right here where it says use this space for finding equations of lines that goes through a point, and you can find parallel and perpendicular. So anyway, you put the slope right here, and the slope on this particular one is 3, and the point that it goes through is 0, negative 2. So 0, negative 2 is what it goes through. And that's here where it says find the equation of the line parallel. Well, this would be the equation of the line or a parallel line, but for this problem it's the line that you want. So the equation of that line is y equals 3x minus 2. See, it's in the form y equals ax plus b. Y equals 3x plus minus 2. And then if you needed to do anything with that, you can click this button, which will put those values. You can always type it in if it doesn't work, but you can just type those values in right over here, and you can get anything you want from that equation. But this just wanted the equation, and it's y equals 3x minus 2. And that's the way all these would work in this area. Then on this, these start the word problems here. So this one, 23, says derive the linear Celsius to Fahrenheit conversion formula from the fact that 0 degrees Celsius equals 32 degrees Fahrenheit, and the body temperature of 37 degrees Celsius is equal to 98.6 degrees Fahrenheit. Let F be the dependent variable. Dependent variable means it's the y variable, so Fahrenheit is the y variable. So Celsius must be the x variable. So a point comes xy, so a point for us is going to come CF, Celsius, Fahrenheit. Celsius, now here's a point. Celsius is 0 and 32 degrees Fahrenheit. So we get a point 032. So let's go over here. 032, and we get another point at, I believe it was 37, 98.6. And click the get equation from data points, and there's your equation right there. Y equals 1.8x plus 32. And then this is completing a table. So like for this one, you put 0 in for f. F is the y variable. When you put 0 in for the y, you're really getting the x-intercept. So the x-intercept here is this one, negative 17.78 would be what goes in here. Now you could check that. You put 0 in for the y variable right down here, and you get negative 17.78. Here, put negative 44 in for the x variable. Put negative 44 in for x, you get negative 47. And you can just do these as you needed to. These would be your x values you're substituting in, these are the y values you're substituting in. This one, Diane deposits P dollars in an account to pay simple interest. After 6 months, the balance of the account is $850, and after 8 months, the balance in the account is this much. Find the equation. Well, you just have 2 points is what you have. You have the number of months, which is your time, which is your x variable. So after 6 months, she has what, $850? So 6 months, 850, and after 8 months, she has however much is said right there, 865.35, 865.35, and there's your equation over there. If you see that these values change, the A and the B, as you type them in, then you don't need to even worry about clicking that button. But that would be the equation. That would be the slope. That's how much her interest is going up, and here's the initial amount that she must have deposited. 27, same type of thing. We're letting 1990 be t equals 0. So 9 years, so we'd have a coordinate 9, 28,500, and another one, 12, 30,250. And you get the equation. This one says 1996 business had this. Well, maybe you might let 1990 be year 0. So 6, 250,000, 7, 340,000. Get the equation, and then put 9 in for x. And then let's go to 31. 31, you just take all these data points. They're on your Excel sheet, by the way, back here on the data sheet. I'll show you that here. If we go back to the data sheet, you can see here section 1, 2, and different examples, and here's problem 30, and here's problem number 31. So you could take these data points here, copy them, and then go to your linear sheet, and right here do a paste special, and we want to paste them as values, and I think that's it right there. Yeah, values. And then there's the equation is right there. So what does it mean? Well, the years after 1990, and then here's household family income, and it says let t equals 0 be 1990. That way, why we have 0, 1, 2, 3, and so on for the x values over here, right here. And then the equation, well, there's your equation. The slope, 1,684.6, means that the household income is going up by this amount every year. This is what the average household income was back in 1990, according to this model. That's the y-intercept. And the x-intercept, right here, means 20 years before 1990, about 21 years before 1990 actually, the average household income was 0. Now that's impossible, but that's out of the domain of this model. So again, I think we answered most of the things here. Correlation coefficient, well, to get the correlation coefficient, that's the R value. So if you see here, the R value is 0.9855. That's a strong positive correlation because that R value is bigger than 0.7. And then this little thing here, use the model to predict the average household income for an American family in the year 2006. Well, 2006 is 16 years after 1990, so you would just put 16 in for the x value. And if you put 16 in for the x value, you'll get 62,277. So that's how these work in this area. You see 32, 33, 30 also was the same type of thing. 34, 35, 36 data points, and you're answering those sort of questions. Let's see, 37 here. According to a recent poll here, let's see, in 1974, about 30% of all 25-year-olds voted in the midterm elections, and in 2002, only about 23% voted. So, see, we have 2 points here, and it says let 1974 be t equals 0. So one point is 0, 30%, okay, and the other one is Well, 2002 is about 28 years later, so 28 years later you have 23%. So that would be your two coordinates that you would put in here for your data points. So we would put in, let me get rid of these, you would have 0, 30%, I'll just use 30, but just remember if I use 30 instead of 30%, I have to use a whole number over any place else for a percent. So, or you could use 0.3, but then just use that the whole time. 2002 is 28 years later, so 28 years later, you'd be down to what? 23%, it says. So that'd be 23. And then there's your equation. So your equation is this right here, y equals negative 0.25x plus 30. And you can see it right here, negative 0.25 is your slope. It means every year the percentage of 25-year-olds that vote is going down by 1/4% is what that means. And this is what how many voted at the start in 1974. 30% voted at the start. Correlation coefficient is, -1 because there's only 2 data points, and that line hits both of those data points, so it's exact correlation, and that's only due to the fact that we only have 2 data points. Here's your x-intercept. This means 120 years after 1974, no 25-year-olds are supposed to vote, and this means at the start, 1974, that's the starting time, 30% voted. And then you can answer anything like like this one here. How many will vote in the year 2022? Well, 2022. The year 2022 is, let's see, that's 26 gets you up there. That's like 48 years later. So you put 48 in for the x value down here, and that would tell you that about 18% are supposed to vote in the year 2022. And you can get here, when will there be 10% to vote? Well, that's a y value. So put the 10%, or just 10 really, since we've been using those whole numbers on this particular problem. So that means 80 years after 1974, 10% will vote. And I think we just about answered everything from this. Down here in these last couple, here's 39, it says find the equation line that goes through that point and is perpendicular to this line. Okay, so first thing you have to do is you have to get this equation in slope-intercept form. So I'm going to take the 8y to the right and the 16 to the left. So I would get something like 8y equals, just writing the left-hand side first, 8y equals, and taking this negative 8y to the right makes it a positive 8y. The 2x stays on the one side, so that's 2x. And the 16 I'd have to move over, so minus 16. And then dividing everything by 8, you have y equals 2x over 8 minus 16 over 8, and that's the same as y equals x over 4, just reducing the 2 over 8, minus 2. So that would be the equation of this line. Okay, so let's put that in. The slope is 1/4 and the y-intercept is -2. 1/4 and -2. So over here, slope is 1/4, so I'm just going to type in 1/4 right there. And then the point that it goes through, see, I don't even need this -2. 1/4 is the slope, and the point that it goes through is -2, 5. So let's put that in. -2, 5. And now we want the equation line perpendicular to it. That's right, what it gives us right here. So that equation of the line perpendicular to it is y equals -4x minus 3. So our answer is y equals -4x minus 3. I believe that's what it had there, and it does. And now, did it want anything else? That's all it wanted. Okay, that's all it wanted. Well, that was a lot anyway. Okay, and then I think we have just about everything on that. So we'll stop it right there.